Hello everyone, you are welcome once more to our class today. Today I'm going to give us a guide on how to solve one of the physics practical question. You see, one of the challenge students have in physics WAEC is the practical. If we were able to solve practical problem, we have solved over 30% of the WAEC problem. So let's look at this question. If you look at any question on practical that comes with rectangular uh, glass block, rectangular prism under optics, there is a general thing we need to know that will guide us to solve questions or to prepare a table even without going to any lab. So how do we do that? So what we are going to look at is what are the general principles guiding rectangular prism. If we understand the general principle, how the question will come is immaterial. There are so many things you can be asked to do in a rectangular prism. There are so many things that can be given as a value in a rectangular prism. But the general thing we should know is that in everything they are doing, in calculating slope or whatever thing you are meant to calculate or evaluate, the main essence of the practical of a triangular prism is to determine the refractive index of that prism. So if we have that at the back of our mind, then our problem is halfway solved. So now you have a rectangular prism. I said I'm going to discuss the general thing we need to know. First of all, we need to know the parts of a rectangular prism. Now, in a rectangular prism, there is a principle which we call the law of refraction. That when a light passes from one medium to another medium of different density, that there is a change in direction, there is a change in speed of the ray when it moves from one medium to another medium of different density. There is a change in its speed, its direction, there is a deviation. So if we know that when light ray moves from a less dense medium to a dense medium, the light ray bends towards the normal. Now first of all, let us label the parts of the ray that moves from one medium to another. Now we have the air, and we have, this is the glass, then this is the air, this is the glass, and of course the refractive index of glass is greater than that of air. That is, the glass is denser than air. Yes. So when you see a light ray moving at a given angle in air, as it gets to the boundary between these two media, the air and the glass, it changes direction. This is the light ray. It changes direction, as you can see. When it gets to the boundary again, in order to return to the air, it also changes direction again. It does not go straight. If this glass was not here, the light ray will move straight, and that is what we refer to as rectilinear propagation of light. Light moves in a straight line. Light does not change corners. But when it travels from one medium to another, it bends. It changes direction. It changes speed. So we can see that. So if that is the case, if a light ray is moving from air and enters glass, it bends towards the normal. What is the normal? The normal is a perpendicular line to the boundary between the two media of different density. That is a line that forms 90 degrees with the boundary. This is the air, this is the glass. So this is the boundary. This line is the boundary between the air and the glass. And the line that forms 90 degrees with this boundary is what we call the normal. So this line is the normal. Then this line that is coming, or the line that is describing the path of ray from a source. This is a source of light. A light ray coming from this source to enter the glass is what we call the incident ray. Is what we call the incident ray. Are we there? Then when the light ray now enters the glass, it bends. If there was no glass here, this light ray would have gone straight this way. But because of this glass, it bends this way. towards the normal. You see, it's closer to this normal than when it was in air. So this ray, that when it enters glass or when it enters another medium, is what you call the refracted ray. Refracted ray. While when it now comes back again to move from glass back to air, this other ray is what you call the emergent ray. Is what you call the emergent ray. So, having known these three rays, the incident ray, the refracted ray, and the emergent ray, the angle between the incident ray and the normal is what we call angle of incidence. Angle of incidence represented with I, usually represented with I. You can use any other thing actually, but generally we use I to represent the angle of incidence. Then the angle between the same normal and the refracted ray, this is the angle between the normal and the refracted ray, is what you call the angle of refraction. We call it the angle of refraction. We can see that. Then the angle between the normal and the emergent ray, this is also a normal because it forms 90 degrees with a boundary between the glass and the air. So the angle between the normal and the emergent ray is what we call the angle of emergence, represented with E. Then we have another angle that we call the glancing angle. We have another angle that we call the glancing angle. The angle between the boundary and the emergent ray, or between the boundary and the incident ray. We call it the glancing angle. We also have another angle that we refer to angle of deviation. If you look at this, I said that this light ray is meant to go straight if there was no obstacle. This glass is like an obstacle to the light ray that is moving in air. So if there was no obstacle as the glass, this light ray would have gone straight like this. But this glass has made it to bend. So the deviation from where it would have gone to where it went is the angle there is what we call the angle of deviation. So we have the incident ray, the ray coming from the light source, the refracted ray, the ray when the light ray moves from one medium to another, then the emergent ray when the light ray returns to the first medium. Then the angle between the incident ray and the normal, we said the normal is the line forming perpendicular to the boundary between two media of different density. So the angle between the incident ray and the normal is called the angle of incidence. The angle between the refracted ray and the normal is called the angle of refraction. And the angle between the emergent ray and the normal is called the angle of emergence. While the angle between the boundary and the emergent ray is the glancing angle. Are you seeing that? So if we know these angles, there are principles that guide this rectangular prism. And what are those principles? Number one is that when a light ray moves from air to glass, or from a less dense medium to a denser medium, the angle of incidence in a less dense medium is greater than the angle of refraction in the denser medium. That means that I is greater than R. The angle of incidence is greater than the angle of refraction. Okay, let's call this place R1 and also call this place R2. We also know that R1 is equal to R2 from alternate angle in mathematics. This angle R1 is alternate to this because this line is parallel to this line. If this line forms 90 degrees with this, and this other one forms 90 degrees with this, and this line is parallel to this, that means that this is also parallel to this. And this is a transversal that is passing through the two lines that are parallel. Therefore, this angle is alternate to this angle. Are you getting that? So if that is the case, that means R1 is equal to R2. And again, if R1 is equal to R2 and I gave rise to R when it refracts, what if the light was coming from here and it will now refract to give rise to this? That means that this angle of emergence, is equal to the angle of incidence. For a rectangular prism, it does not occur that way in triangular prism. So if we understand this, that this angle of incidence is the same as the angle of emergence, that this R1 is the same as R2, that when I add R1 and D is the same as I, that is the angle of refraction and the angle of deviation here will give me angle of incidence. So if we know that, another thing we ought to know is that the incident ray is parallel to the emergence ray. The incident ray is meant to be parallel to the emergent ray. That means this ray should be parallel to this ray. So if that is understood, it means that if you are performing an experiment using a rectangular glass prism, you should know that whatever the incident ray is, it should be parallel to the emergent ray. So that will give you a guide on what you are meant to do. Let us not begin to discuss this in detail. I didn't come to discuss this, but I came to give us what we need to understand in order to answer questions in practical. Now let us give ourselves a practical question. Say in one practical exam, you are given that, let's say alpha is an angle given as maybe 30 degrees, 35 degrees, 40 degrees, 45 degrees, 50 degrees, 1, 2, 3, 4, 5. Usually 5 or 6. And then a diagram is drawn this way. You are asked to use a plain paper to produce this thing. Place your rectangular block on the paper and trace the outline of the block as in the diagram. So you'll be given a diagram, something like this, and then you are given this. They call this place alpha. Okay, and I'm using the simplest form of it. Definitely we may still go deeper, and then you have something like this. Let us even stop here. And you are asked to find beta. Okay, you are asked to find beta. You are asked to produce a table, find beta, then find sine alpha, and then find sine beta. So if that is the case, that means we are going to have a table that contains alpha, beta in degrees, sine alpha, and sine beta. So these are the 4 things we are asked to deduce from this practical. Then from our table we now recreate these values that was given: 30.0, 35.0, 40.0, 45.0, and 50.0. In WAEC exam, it is advisable to always leave our given value to at least 1 decimal place. At least 1 decimal place. This is the given value. The value that you are given in the question is what we call the given value. We have the measured value, and then we have the calculated value. There are 3 values that we obtain from a practical table: the given value that is existing in the question, the measured value that you use any measuring instrument, your stopwatch, your protractor, ammeter, voltmeter, or whatever measuring instrument that you can think of is the measured value. Then the calculated value is what you now evaluate from the measured value and the given value, like sine theta, sine alpha, sine beta. Now if you look at this diagram, this is the place we call the angle of incidence. This is the place we call the angle of refraction. And from the law of refraction, the one we call Snell's law, it says that the refractive index of a prism is the ratio of the sine angle of incidence to the sine angle of refraction. The ratio of the sine angle of incidence in a less dense medium to the sine angle of refraction in the denser medium, or the ratio of the sine angle of incidence in a medium to the sine angle of refraction in that medium that you intend to determine the refractive index. So if I am looking for a refractive index of glass, this refraction should be inside the glass. If I'm looking for the refractive index of air, that means this is air. The refraction is the air. So if you look at this, it means that our I here is going to be alpha and our R is the beta. So the refractive index of this glass is the sine alpha over sine beta. Now the truth is this: in most cases, the refractive index of the glass we use in WAEC is usually within the range of 1.4 to 1. Between 1.45 to 1.55. So I will always advise you know the refractive index of the glass you use in your own school. So if I am using 1.5 as the refractive index of the glass we use in this school that we are using as a model, and then we are asked to produce this, I don't need to go to any lab. I don't need to begin to trace, put pin here, look there, look, because what the wire will tell you is to, okay, produce one, place a pin P1, place another pin P2, you label this P1, P2, draw an outline of this, place a pin, measure angle 30 degrees probably, and then place P1, P2 on the line you drawn as the angle of the incident ray. Then look through the prism at this other end such that you will be seeing the image of these two pins from this end, and then you locate the two pins from this end to be on a straight line, and then place another two pins to be on a straight line with the image, not with these two, but with the image of these two pins, because it is these two pins that has gone into this and refracted. So when you look here, it will emerge from here. So you are seeing the image of these two pins, and from where you see it, place another two pins so that it will be in a straight line with the image. And then when you have done that, you now draw a line to join the 2 points and make it meet this place. And wherever it meets this place, wherever this one is not supposed to be drawn, there it is when you have traced from here, you place your pin here, you look through this end and see the image of these two pins, then place the two pins here, draw a line to join the two pins. Wherever it meets this glass, then you join these points to these points. That will produce this beta. That is exactly what you are meant to do in the practical. But we can do this because sometimes you even trace. Some students will begin to look, they will be telling you, I'm not seeing it, I'm not seeing it. Oh, quite alright. If you're not too careful, you might not see it, and even if you see it, you might not actually locate it very well. If you have, most times, even if you have eye problem, it becomes a problem. But even if your eye is not seeing well, you can actually perform this experiment, get it perfectly well, and get your mark in full. So what am I going to do? What I'm going to do is that I don't even need to trace anything. What I'm going to do is to use this formula. Knowing my refractive index, let's assume 1.5 to be the refractive index of this glass. So like I said, you should know your refractive index before you enter WAEC hall. Yes, your teacher should be able to tell you that from the experiment you have done in your school, the glass that is going to use, he knows it. So because every school is unique, whatever the school uses, everybody in that school should be able to use that. So you should know the refractive index of the glass used in your school. So if we assume it to be 1.5, what I will do is that this is the refractive index, 1.5. equals sine alpha, which here I use 30 as the first value given, sine 30 over sine beta, which is what I'm looking for. I'm looking for beta. So what I will do now, of course, you know, mathematics will begin to submass here, will cross multiply, so that sine beta will be equal to sine 30 over 1.5. So because I'm looking for beta. So if I make beta the subject of the formula, I'll have the sine inverse, because this sine will come and be inverse here, of sine alpha over 1.5. So I will use this as a formula to get my values here. I'll use this as a formula. So how do I do that? Okay, I'll say beta is equal to sine inverse. At the first instance, I have what? Sine 30. I put 30 here, it becomes sine 30. Sine 30 is 0.5. That means I have 0.5 over 1.5. And 0.5 over 1.5 will give me sine inverse of 0.33. 0.333. Okay? Sine inverse of 0.333. So if you do this, whatever you get here becomes your beta. You do it again when alpha is 35. So Beta is going to be what? The sine inverse of sine 35 over 1.5. You see that? If we do this, get the sine of 35, divide it by 1.5, whatever you get to find its sine inverse, that becomes this other value. You do for 40, sine 40 over 1.5, then the sine inverse, you get this one. For 45, sine 45 over 1.5, then the its sine inverse, you get this one. Sine 50 over 1.5, its sine inverse, you get this one. So if you have gotten all those values now, remember this is the measured value. This is actually supposed to be measured after you have done your traces. You are supposed to remember what I said. You're supposed to look through here, locate the image of this pin, place your own pin again, then trace the outline. Then wherever this outline here met this point, join it with where the other this outline met this point in the straight line. Then the angle formed becomes your beta. That is what you are meant to perform ideally. But we didn't even perform it and we are getting values. After getting values, you now use these your values to produce your traces. Remember, in optics, there is always a diagram. You must have a trace in a plain paper. Get that plain paper, just place it. Use your glass block, create an outline. After you have created that outline, draw this normal. Measure 30 degrees as we've done. Use your protractor, measure 30 degrees. I'm not teaching you how to measure now, just a trick on how to get these values without going to lab, without performing an experiment. Measure this 30 degrees, draw a line. Then how do we get this one? We have already gotten it. Come here, measure whatever you got here, then draw this line. Then when you come here, remember from our principle, we said that the angle here is going to be the same as the emergent angle if we draw a number here. But in the practical, they didn't draw a number, so you are not meant to draw a number. If we know that if this angle is the same as the emergent angle, then this angle is the glancing angle that is the same as this glancing angle. So since we don't have number, we will be using the glancing angle to create a glancing angle here as well. Because we must draw this line in order to produce our pins. So what do? What we are going to do is to, when this is 30, this place will be 60 because this angle is 90 degrees. So this angle and this angle are complementary. When this is 30, this is 60. When this is 35, you remove 35 from 90, you have 55. When it is 40, here is 50. So it is this angle now that you are going to be measuring here. So at 30, this place will be 60. This place will be 60. So you place your protractor, taking this point as reference, measure 60, and then draw a line. Remember, how did we get this one? We got this one from this calculation. These values here, we use it to produce beta, and then we draw a line. Wherever it meets here, use your protractor to measure this glancing angle, and then draw this line. After you've done that, you've done your traces. Just use pin. Even if you don't have optic pin, go to your master, get your divider, perforate this place, perforate one here, perforate one here, and nobody will say you've not done that experiment. You do again for 35. At 35, you have already gotten a value here. So you place your protractor, you have your outline, place your protractor, measure 35, draw this, come here, measure what you got here, produce it, draw a line. Wherever it meets this, measure 90 minus 35, that will give you this place. That is 55. Measure 55 here, draw this one, use your pin, perforate. You are done with 35. Do the same for 40, do the same for 45, do the same for 50. These other ones are calculations. Just punch, sign this, you get this place. Sign this, you get this place. And you evaluate the other things. Whatever you are asked to get, even if it is not this alpha and beta, the same principle. Let's assume you were asked to produce, there is one that they said, instead of giving you here, you are given here. You are given here. It does not matter. If you are given here, if these values are values for this place, all you need to do is to know that this formula is meant for this and this. So I would have, if I want to get this place, I will only say 90 minus this 30, this place will now be 60. If these values are for this glancing angle that was given, and maybe you are asked to find this one, it does not matter. All you need to do is 90 minus this will give you what you have here. Take it here and then find beta, which is this place. But since you are not asked to find here, it is here you have to find. Whatever you get here, remove it from 90. That will be this. So it does not matter what you, even if it is this line you are measuring, it is still the angle you are going to use to produce whatever calculation you are producing. The only difference is that what will now be reproducing on your table will be dependent on what you are asked to produce. But this formula applies for every one of them. So we will see next time in the next class. I will not pick one particular question that we will use this principle to solve. Thank you and see you in that class.